In this video, we are going to discuss few concepts from planes, and we'll be using these concepts for solving questions in the coming videos. So first one is equation of the planes bisecting the angles between two given planes. So we have two given planes. Let's write the equation of two given planes: a1x plus b1y plus c1z plus d1 equal to 0. Let's call this plane 1. And a2x plus b2y plus c2z plus d2 equal to, let's call this equation 2. Now they are asking equation of the planes bisecting the angles between the two given planes. So I will just draw two planes. So just consider, let's call this plane 1 and this is plane 2. Now we have two, whenever two planes bisects, two angles are formed. This is the acute angle between these two planes, and this is the obtuse angle that is formed. So we are to find the equation of a plane bisecting these two angles. So there will be two bisecting planes. Just draw one. This. So this is one bisecting plane. As you can see, it bisects these two angles. Another bisecting plane is like this, which bisects this angle. This is equal to this angle. These are the two bisecting planes. Now we are to find the equation of the bisecting plane. For that, we will be using the concept. If you take any point in this plane, bisecting plane, and if you draw a perpendicular to these two planes from this point, these distance will be equal. So if you can see, we have a plane like this. So we have a, so I am converting this 3D figure into a 2D one. Let's say planes looks like this. So this is the bisecting plane, and this angle is equal to this angle. Now from this point to this plane, you see, since these angles are equal, this distance will be equal to this distance. This concept will be used to find the equation of the bisector plane. Let's see how. So let P x1 y1 z1 be a point on bisecting plane. Okay. Distance from P to P1 is same as distance from P to plane 2. So how what is the distance formula from x1 y1 z1 to the plane 1? The formula is a1 x1 plus 8 sorry b1 y1 plus c1 z1 plus d1 by root of a1 square plus b1 square plus c1 square. This is the distance from x1 y1 z1 to plane 1, this plane. Now to plane 2, to say that these two distance are equal, then distance from x1 y1 z1 to plane 2 will be a2x1 plus 2 plus z1 plus d2 2 I of a2 square plus b2 square plus c2 square. Now distance from p to p1 is equal to distance of point p. If you see, point from any point p to plane 1 distance, and perpendicular distance from the bisector plane to plane 1, and the perpendicular distance from this point to another plane 2. So equating these two distance. So now, as you can see, any point on this bisector plane will satisfy this. So equation of a plane, therefore equation of bisector plane can be given by simply replacing x1, y1, z1 by with x, y, z. So since any point on that bisector plane satisfies this condition, so we can say equation is this. Sorry. So this is the general equation. Now we have a small problem here. So whether if you take the red plane also, you take the red plane and any random point on the plane 1 and draw a perpendicular like this. Say this is the perpendiculars. This distance will be also equal. Then this equation satisfies plane red plane also. So how will we find whether this given equation represent the yellow plane or the red plane? So where little complication comes. Since in this, when you derive distance like this, we are considering the sign of this. We need to stick on to some particular direction, or like we have to take we usually when we draw figures, we consider the distance from origin to the plane. When we calculate the perpendicular distance from any point to a plane, we usually calculate the distance from origin to the plane in the positive direction. So will I explain? Wait, if we have origin here and plane here, another plane here, so origin to this plane, distance from origin to this plane and origin to this plane is considered positive. This is the positive direction. As far as distance is perpendicular distance is considered, we consider this positive. But if say we have a point here, so we have a point here, so the point distance from point to this plane will be considered negative, since it is opposite to the direction from origin to the plane. So we will use this convention to differentiate two planes here. So what we are going to do is, I will explain on this concept more, but we are going to say is, if equation of bisector plane that bisects the angle that contains origin is the given one, a1x plus b1y plus c1z plus d1y of a2x, sorry, a2, sorry, a1 square plus b1 square plus c1 square equal to a2x plus b2y plus c2z plus d2y root of a2 square plus d2 plus. This is the equation of bisector plane that bisects the angle that contains origin. So the other bisect, the plane which bisects angle bisects the other angle. Other angle means the one which does not have origin. I will draw and show you what that means. Angle is just this same equation, but we have a minus sign here. We put a minus sign. So these are the two equations of bisector planes. This is the bisector plane that contains origin. So what does that mean? So I will just show you. Suppose we have two planes like this which bisects. And this is the one angle, and if origin is here, if the origin lies in this angle, if the origin appears here, then this positive equation represent the bisector plane that bisects this angle. This plane is represented by this equation, and the other angle, which is this, which does not contains origin, and the bisector plane that bisects this angle is represented by this equation. This is what visually it means. So we'll discuss the concepts like uh, the concepts related to this in detail uh, soon, but so the reason why this happens is because of the signed direction. See, there is one more requirement. I forgot that. For this to work, first we should make this d1 and d2 of same sign. So why that happens? If you suppose if we have, what does that mean? Suppose we have the plane equation as 2x plus 3y minus z plus 2 equal to 0, and say minus 4x plus y plus 2z minus 4 equal to 0. So here d1 is of plus sign and d2 is of minus sign. If this is the scenario, we have to convert this 2 into same sign by throughout multiplying. So we by multiplying by -1. So we can convert this equation d2 to positive by multiplying throughout by positive -1. So 4x, it becomes 4x minus y minus 2z and plus 4. So this now d1 and d2 are of same sign. We just need d1 and d2 be of same sign. The reason for that is as you will see when we are going to check whether origin lies in where the origin lies. So when we check whether origin lies in the acute angle or the obtuse angle, we'll get an equation something like this: d1 d2 into a1 a2 plus b1 b2 plus c1 c2 is greater than or less than 0. Greater than 0. This will be the condition for the origin to be in the acute angle or obtuse angle. We'll see what that condition is. But here it will come when you derive it. There will be a term like d1 d2 into this. So once we make d1 d2 of same sign, then we can ignore this part and we can just focus on this part to find where the origin lies. So that is the reason why when we derive, we get a part like this. So instead of bringing that also as a factor, what we do is in such questions, we always keep d1 and d2 of same sign. It could be positive or negative. It doesn't matter. It has to be of same sign for this to work. So once we have placed this d1 and d2 of same sign, then we can use these two situation. These two becomes here the equation of the bisector plane that is given by this positive sign represent the angle, uh, um, um, the bisector plane that bisects the angle which contains the origin. So and this negative sign equation represent the equation that equation of the bisector plane that does not contain origin. So what are the two scenarios? I'll just say, so just consider this the 2D version of a plane. Yeah, if the origin is in the acute angle, this is the acute and this is obtuse. If origin is in the acute angle, then equation of the bisector plane, this equation will represent the equation of the bisector plane that cuts the acute angle. But if the origin is at the origin is in the obtuse angle, then this equation, the same equation will represent uh, the bisector plane that bisects the obtuse angle. So this equation will always represent the equation of the plane that bisects the angle which contains the origin. That is the easier thing to remember. The plane that bisects the angle which contains the origin. And when negative sign is there, it is the plane that bisects the angle which does not contain origin. So we'll see few more concepts here. This is the equation of the bisector plane. Two type of there are, whenever the plane bisects, there are two angles, one acute and obtuse angle, and there will be two bisector planes. So those two planes are represented by these two equations with a positive sign here and a negative sign here. This is the derivation. I hope you understood this part, and we will move on to the next part. Once we deal with how to check whether the origin is in the acute angle or the obtuse angle, you will get more clarity. Just hold on to this. We'll see the other part. So next one is how to check whether the bisecting plane bisects the acute or obtuse angle. Although we said here, this is the equation of the uh, plane which contains origin. We still doesn't know whether the origin lies in the acute angle or the obtuse angle. We want to know whether the given bisector plane. So we found out the equation. How we will check whether that bisector plane bisects the acute angle or sorry for the poor drawing doesn't look like a plane. So just imagine two planes are like this, and we have, this is the obtuse angle and this is the acute angle. So we have, as I said earlier, we have two bisector plane. We know how to find the equation of a bisector plane, and we want to know whether this equation represent the angle, the plane that bisects the obtuse angle or the plane which bisects acute angle. So how do we check that? For that, we are going to find the angle between a plane, one of the plane, bisector plane, and one of the plane. So say this is the bisector plane. Okay, I will just mark this plane 1, plane 2, and this be plane 3. Now what we do is we have an equation. Say um, um, we don't need to write the equation. So we just use the formula to find the angle between the two planes. Say theta is the acute angle between plane 1 and plane 3. So why acute angle? Whenever if you went and look for the angle between plane 3 and plane 1, there will be one acute angle and an obtuse angle. So always whenever we find the angle between two planes, there will be an acute and obtuse angle. So for that, what we do to find the acute angle is, like, say the equation of plane 1 was, earlier I said a1x plus b1y plus c1z plus d1. So direction ratios of the normals to the plane 1 will be a1, uh, b1 and c1. C1 will be the direction ratios. And say the direction ratios of the bisector plane we got as a3, b3 and c3. So we will find theta by using the concepts we discussed earlier. Cos theta is nothing but a1 a3 plus b1 b3 plus c1 c3. We will find this theta, and if cos theta is negative, that means this angle is obtuse. So we will take the acute angle between these two planes, and once we get the acute angle between these two planes, now we will check whether we will check what is the tan theta. What is tan theta? Tan theta is nothing but uh, root of sec square theta minus 1. We have cos theta here. From 1 by cos theta is sec theta, and square it sec square theta. Root of sec square theta minus 1 gives tan theta. And once we find tan theta, we will check whether tan theta is, if tan theta is less than 1, that therefore that means theta is less than pi by 4 or 45 degree. So once we find the angle between these two planes, we will check whether this angle is less than 45 degree or not. So if this is less than 45, that means this whole angle is less than 90 degree. So as you can see here, if we go and find out, we'll get that this angle is not less than 45 degree. So we can say that this whole angle is greater than 45 degree. So by looking at tan theta, we'll see the angle between the bisector plane and any other plane. We could take this plane also. I randomly took plane 1 and plane 3. You could definitely take plane 3 and plane 2 and check angles between them. And if that acute angle between those two planes is theta, and if tan theta is less than 1 and we get theta is less than 45 degree, then we can say that, therefore we can say that if this is true, then uh, bisector plane bisects acute angle. If tan theta is, so if tan theta is greater than 1, that is theta is greater than pi by 4 or 45 degree, then bisector plane bisects obtuse angle. Okay. So this is how we find whether the bisector plane is bisecting the acute angle or obtuse angle. So we first formulate the equation of plane 3, then use the direction ratios of the plane 3 and plane 1 to find the theta. We take the acute angle, then tan theta, we check tan theta is less than pi by 4, and from that we can know whether this bisector plane the one we took is bisecting the acute angle or obtuse angle. This is the method to do it. Now, another concept we are going to discuss is whether this origin lies in the acute or obtuse angle. So that is the next problem. So the next problem, by problem I mean, so I said earlier we discussed we could find the equation of the plane, bisector plane, that contains the origin, right? So here we are going to discuss the concept of finding whether when two planes bisect each other, finding where the origin lies, in the acute angle or the obtuse angle. Let's see. So these are the, say this is how the plane bisects, and for this let me just draw. This is say this is how the plane bisects, and what we do is, suppose the origin is here, suppose the origin is here, origin is in the obtuse angle. We'll check how. So what we do is, we can, to understand this, we can draw a perpendicular to this plane. This plane we perpendicular, and so we'll draw a perpendicular. Now you see, if you form something like this, a quadrilateral like this, you can check what this angle is. Say now we know that this is 90°, this is 90°, and we can check what this angle is. Say this angle is alpha and this angle is theta. Now if alpha, so how we can find alpha? We know that when we draw a perpendicular from the origin to the planes, we know the direction ratios of normals. These are normals, so we know the direction ratios of normals, and we can find this alpha. So if you remember, the definition of the angle between the planes, we have to have some clarity here. Angle between the planes is defined as, if you remember the concepts, earlier concepts, angle between the planes is defined as angle between the normals of the plane. So as I said before, whenever we take angle between the plane, there will be an acute angle and obtuse angle. So we always take the acute angle between the normals of the plane. This is how, when we say find the angle between the planes, we usually take the acute angle between the normals of the plane. That is, if you see, the acute angle between the normal is whenever suppose there is two planes like this, say I am going to draw a 2D version, and we draw perpendiculars like this, and we get two normals bisecting like this, and say we have two angles. So here it looks like exactly 45 degrees. So I'll just show you a different example. Suppose we have planes like this. Okay, so normals are intersecting. This is normal and this is normal. So angle between the normals, when you say angle between the normals, there will be an acute angle and an obtuse angle. If you say angle between the normals of the plane, there will be an acute angle and an obtuse angle. We take this acute angle as the angle between the planes. So as you can see, this obtuse angle is what come here, and 180 minus this angle is nothing but this angle. So angle between the planes is nothing but the acute angle between the normals of the plane. So here we are not going to worry about the angle between the plane. What we worry is, what we are going to find is whether the origin lies in the acute or obtuse. So when we say acute and obtuse angle, we mean this angle only, acute angle, and this is the acute angle and this is the obtuse angle, definitely. So whether origin lies here or origin lies here is what we are going to find. So if alpha is obtuse, if since the entire angles of this will be sum to 360 degree and this is 90, 90, 180 degree, this sum has to, this is complementary angles, like alpha is nothing but 180 minus theta, or theta is nothing but 180 minus alpha. So if alpha is obtuse, then theta is, we can say that. So when we find the angle between the normals, angle between we get what, cos theta. We are getting cos theta is equal to a1 a2 plus b1, sorry, b1 b2 plus c1 c2. So if this cos theta is less than 0, what does that mean? The normals are forming an obtuse angle. Is less than 0, that implies alpha is obtuse. If alpha is obtuse, then that implies theta is acute, or origin is in the acute angle. Similarly, if cos theta, same thing, cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 is greater than 0, that is positive. If cos theta is positive, that implies alpha is acute. That implies theta is obtuse, or origin lies in the obtuse angle. So looking at whether a1 a2 plus b1 b2 plus c1 c2 is less than 0, we can find whether origin lies in the acute angle or obtuse angle. Here also remember that d1 d2 has to be of the same sign. So how this, if you check, this is origin and suppose this is the foot of perpendicular to that plane. So suppose this is the first plane. So first plane, so this is the second plane, and this is the, suppose this is the foot of perpendicular. And now you can there is a formula for finding foot of perpendicular. What is that? So our plane is a1x plus b1y plus c1z plus d1 equal to 0. a2x b2y z plus d2 equal to 0. And there is the formula, this point we can find out by substituting 0 0. So 0, we get d1 by root of a1 square plus b1 square plus c1 square as this point, and we get d2 by root of a1 square plus b2 square plus c2 square as this foot of perpendicular. Now we can find the direction, we can find this angle if you want. If the angle between these two, we can using this foot point, we can find the drs. One second. If we check, if we use the formula, second. So here, if you want, to check this angle alpha. Let's say this point is q and this p. Now we have cos. We need to find cos alpha, and we know that cos alpha is here. If you assume this theta and theta is obtuse, then alpha is acute. Then cos alpha will be greater than 0, right? Sorry. In our figure, obviously this angle theta is obtuse angle, and this alpha is acute angle. So cos alpha will be greater than 0, and we know that cos alpha is nothing but vector OQ dot OP by OQ dot OP. Now, if you see, you go and find the foot of perpendicular, you will get something like this is the distance, and if we assume x, y, z, this point is x, y, z, then we know direction ratios are a1, b1, and c1. So it will be so x by a1 will be equal to y by b1 equal to z by c1. Reason being, this is 0, 0. So x minus 0 by a1, y minus 0. So that becomes y by b1, z by c1. This we know, and distance, that is the and one, if you take a unit vector and product it with the distance, we can do it this way also. Put it k and put x as a1k, y as b1k, and z as c1k, and substitute in this equation, and then eliminate k. Then we will get what x if you find x in such manner, we will get x as a1 into minus a1 into d1 by root of a1 square plus b1 square plus c1 square. Similarly, you get y as b1 d1 and z as c1 d1. So, and when you apply it in this equation, x y z, if you find x y z and apply it in this equation, it will finally reduce to this form, d1 d2 into a1 a2 plus b1 b2 plus c1 c2 should be greater than 0. So if since we took d1 and d2 of same sign, here we can assume this is greater than 0. So ultimately this has to be greater than 0. So a1 a2 plus b1 b2 plus c1 c2 becomes greater than 0. And in such case, as we saw here, if it is greater than 0, alpha is acute and theta is obtuse, and origin lies in the obtuse angle. That is how the proof happens. So if you know this, you just have to remember this. If you know the derivations, it will be more clear. That's all. So these are the points I wanted to discuss. So we have a method to find whether the origin lies in the acute or obtuse angle, and check whether the bisecting plane bisects the acute or obtuse angle, and equations of the two different bisector angles. And the bisector angles, this equation, this positive equation is given. It gives the bisector plane that bisects the angle which contains the origin, and negative sign gives the equation of bisector plane that does not contain the origin. So these are the equations that we will be using in the following. So I hope this is clear. If you video, I'll try to explain. If this is quite difficult question to visualize because of the signs, the directions, and all involved, and the and angles. Since if you take a direction ratio a1 b1 c1 instead of minus a1 b minus b1 c1, you get the same direction but in the opposite direction. So when we just consider the absolute numbers, we could mess this up. So that is the confusion involved in the whole concept. So we have to follow some standard notions so that we don't we won't mix it up. So yeah, okay. So remember, while solving this question, it's always better to keep d1 and d2 of same sign, and this use this convention. Okay, so yeah, thank you. We'll solve few problems in the next videos.